we're back. This is part 2 of the flipped classroom for balancing equations. And these are the rules, so go ahead and make sure you have your notes handy. And the key is we need to have the same number of each element on each side. And that is similar to when we're baking. Whatever I have for cups of butter, say I want to make 112 cookies. So the 2 cups of butter, they're not going to disappear. They're going to be in those cookies. If we have 4 cups of flour, all that flour is going to be in those cookies. So that's the same concept we're dealing with when we balance these equations. Okay? So you want to find the reactants and products. I'll step you through a couple examples here in a second. Write the chemical formulas if they aren't given. Sometimes they'll be given, sometimes not. Do an atom inventory. That'll be an important step. Balance the equations by changing the coefficients only. All we can change are the numbers out front. Once you write a formula, you don't change the formula. You'll see that in just a little bit. Reduce the coefficients, the numbers out front if needed, add the states if needed. We'll kind of avoid doing the states for a little bit. So here's the hints. Start with the atoms that appear only once on a side. Finish with atoms that are by themselves. You'll see that in a little bit. That's an important hint. It's probably the most important one. And you want to do H2O last. Do water last if there's no atoms by themselves. That'll be a pretty big one too. But the biggest one is that second one. Finish with atoms that are by themselves. Okay? All right, so here's the first example. And we'll go ahead and follow through our steps here. You have the steps in your notes, but we'll find the reactants and products. So we know propane. Propane is a natural gas. It's also what you use for your barbecues. So it reacts with oxygen gas. So C3H8. And you'll see I write a line out front indicating I can put any number I want there. So you'll see when I write reactions, there'll be a line out front. I suggest you do also. Oxygen gas. This is your diatomic, so this is where it's O2. So this is where that diatomic rule comes into play. To form, there's my arrow. Carbon dioxide gas, so CO2, and water. Okay. So this first one, I'm going to do similar to what we did in class. So we're going to model these with a couple methods in class, and I'm going to do one of these with how we did in class. If that helps you to think about these things, that's great, go for it. So what we did in class is we used the paperclip model. You can also use the element model. And so I'm going to use the element model. If you want to think about this with paper clips, that's fine. Feel free. So what we have here is C3. So we got 3 carbons and 8 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. 2 oxygens. Now I wrote the C3H8, I wrote the carbons and the hydrogens up and down just to save a little space. So you can do it either way. I put the oxygens next to each other, that's fine. Form CO2. I'm going to go up and down just to save a little space. And H2O. Okay. So hopefully you realize, you notice right off the bat it's not balanced. 3 carbons here and 1 carbon there. So similar to what we did in class, I just work my way left to right if I'm using this model. So 3 carbons, I have 3 over here. I can put any number out front that I want here. So I'm going to put 3 there. That'll give me 3 CO2s. So that balances the carbons. Let's go ahead and work our way left to right. Hydrogen next, we have 8 and 2. So we'll put a 4 there because we need 8 hydrogens. That'll give me 4 H2Os. Each of those H2Os has 2 hydrogens, so 2, 4, 6, 8. 2, 4, 6, 8, that'll balance my hydrogens. And now obviously we've got to clean it up with oxygens. So 2, 4, 6, make sure you do a total count. 2, 4, 6, 7, 8, 9, 10. So each one of these has 2 oxygen in it, so we're going to need 5 of them. And that should balance it. 3 carbons, 8 hydrogens, 8 hydrogens, 2, 4, 6, 8, 10 oxygens, 2, 4, 6, 8, 10. So that's balanced. So let's go ahead and finish this out. Oh, I forgot to put the 5 in here. So 1 propane reacts with 5 oxygens to produce 3 carbon dioxides and 4 H2Os. the number of atoms, the number of elements that I start with has to equal the number of atoms, the number of elements that I finish with. So that's using the model that we did in class. What I'm going to be doing the rest of the time is the atom inventory model, which is what we'll be using in class in the future. So this is the same reaction. So if you want, you can pause the video and rewrite the reaction. I'm probably going to leave you enough room on the notes to do both of these methods. So our steps are, write the chemical formula, we did that. Do an atom inventory. So this is how we do the atom inventory. We're looking on the left side of the arrow and the right. So we have some carbon, we have some hydrogen, and we have some oxygen. Go ahead and do your count. So on the left we have 3 carbons. On the left we have 8 hydrogens and 2 oxygens. On the right we have 1 carbon. Hydrogen is 2. But be careful with the oxygen. It's 2 plus 1 is 3. So oxygen is in 2 different places. So we need to make sure that we do the total count for oxygens. So it's obviously not balanced. If you go back and look at our hints, finish with atoms that are by themselves. If you look at this one, oxygen's by itself. So we want to do that last. Uh-oh. Come on. My board freezes occasionally. There you go. So we want to do the oxygen last. It's by itself. You'll see why in just a second. It'll become clear. That's a pretty important hint. And you do it, if you did it in order, you do the oxygen last anyway. So, but you'll see that become a little more evident in another example. So we have 3 carbons on the left. We want 3 on the right. So we'll put any number we want up front. So we'll put a 3. The key now is, and this is a common mistake, is people will just add 3 to the oxygens. You got to make sure you do a total recount. So you got to make sure you recount everything. So 3 times 2 is 6, plus 1 is 7. So now we have 7 oxygens. That's probably the most common mistake. Most common mistake. So carbon's balanced, 3 and 3, yep. Hydrogen, 8 and 2. So 8 and 2. Put anything we want out front, so we'll put a 4 here. So that'll give me 4 times 2, 8 hydrogens. Check. And again, this is the error. People will add 4 to this, but you've got to do your recount. 3 times 2 is 6. 4 is 10. And the beauty of finishing with the ones that are by themselves, I put any number I want there, it affects nothing else. I need 10 oxygens, I have 2, so I'll put 5 there. And that gives me, this is my board freezing, this is when it gets frustrating. Grab the other pen. So I like to do a final check. 3 carbons, yep. 8 hydrogens, 4 times 2 is 8, yep. 5 times 2 is 10. 3 times 2 is 6, plus 4 is 10, yep, it's balanced. And so we ended up at the same conclusion as we did with the other method. This method works for basic ones, but if you get into more complex ones, which we'll be doing in a little bit, it gets a little involved. So I prefer that you're comfortable with this. I'm going to do the rest of the examples using this method. All right. So here's the second one on the notes. So nitrogen gas and water vapor are formed, key statement there, are formed when hydrogen, this is rocket fuel, liquid, and dinitrogen tetroxide liquid react. Since these are formed, they're going to be on the right side. Nitrogen gas, remember nitrogen's a diatomic, it's highlighted, so N2, and water vapor are formed. Hydrogen is a reactant, and dinitrogen tetroxide, N2O. Okay, so that's find the reactants and products we just did. Write the chemical formulas if they aren't given. We wrote the formulas. Now we'll go ahead and do an atom inventory. So if you want, you can go ahead and stop the video and use the formula method. So you can go ahead and write out the formulas and things like that. I'm not going to do it that way. I'm going to go ahead and show the atom inventory method. So, and if you want, go ahead and stop the video, and you can try doing the atom inventory by yourself. And then you can come back and turn the video back on and kind of see how you did. So if you want to go ahead and try this on your own before watching me work through it, go for it. And then you can come back and watch me work through it. So, okay. So let's take a look at our atom inventory. We have nitrogen on this side, hydrogen, and oxygen. Be careful, nitrogen's in two places. So let's do our count. We've got 2 nitrogens, and 2 is 4. Hydrogen's 4, and oxygen's 4. On the right, nitrogen's 2, it's only in one place. Obviously not balanced. Hydrogen is 2, and oxygen is 1. So it's definitely not balanced. Okay? So let's take a look at our hints. Our hints were finish with ones that are by themselves, or finish with water. The main hint is if it's by itself, you want to finish there. So we don't want to start with nitrogen, we want to do nitrogen last. So do nitrogen last. Okay. So let's start with the hydrogen. So the first step would be 4 and 2. So 4 hydrogens here, 2 here, so you place a 2 there. So that gives me 4 hydrogens, so we're okay. And then you need to recount your oxygens. So that gives us 2 oxygens. All right. It's like, whoa, something's up here. We got 4 on the left, but only 2 on the right, so that doesn't work. And sometimes that'll happen, where you kind of start working through it, and it's like, this isn't falling into place. And so the hints there is if it's not working for you, make sure you wrote the formulas correctly, and we'll review this in class a little bit. And we did write the formulas correctly, so I'm confident there. Make sure you did your count right, and we did the count right. And then if it's not working for you, maybe start with a different one. So we started with hydrogen here. Let's go ahead and go back. So go ahead and you can erase this. And there we go. So go back to our count, and our count was correct. Instead of starting with hydrogen, sometimes you got to start with the other one. Sometimes you got to do a little guess and check it. So oxygen's 4. So we're going to need 4 over here. So let's put a 4 there. Again, we put anyone out front. Okay. That gives me 4 times 2 is 8 hydrogens now. So 4 and 8. 4 on the left, 8 on the right. So we'll put a 2 here. That'll balance my hydrogens. Check. But that changes my nitrogen. So don't forget, you got to do a recount. If you got the number out front, it affects a couple atoms. So nitrogen, 2 times 2 is 4. Plus 2 is 6. And now the beauty of finishing with nitrogen, put anything I want there, affects nothing else. Put a 3 there, it gives me 6 nitrogens. 2 times 2 is 4, plus 2 is 6. 3 times 2 is 6, yep. 4 hydrogens, times 2 is 8. 4 times 2 is 8, yep. And then 4 oxygens, 4 oxygens. So there's your balanced reaction. 2 N2H4s react with an N2O4 to form 3 N2s and 4 H2Os. Okay? Alright, next one. Oh, I was going to do something a little bit different, so don't worry about that. So here we go. Copper 2 carbonate is heated. It forms copper 2 oxide and carbon dioxide gas. So the first step is, let's write our formulas. Copper 2 carbonate, I like to write the charges above these. Cu2 plus, CO3 2 minus. Is heated, it forms copper 2 oxide. Copper 2, Cu2 plus, O2 minus. So copper 2 carbonate is heated. Crisscross, this wants to lose 2, this wants to gain 2. So it's a 1-to-1 ratio. Crisscross and reduce, if you want to think of it that way. It's heated, it forms, so forms is my arrow. Copper 2 oxide, lose 2, gain 2, crisscross, and reduce, C2O, and carbon dioxide gas. Okay, so there's our equations. Go ahead and pause the video and do your atom inventory, and hopefully you notice something with this one. So go ahead and pause the video and do your atom inventory. So hopefully you realize this one's actually already balanced. And that happens occasionally. So let's go ahead and do our count just to make sure. Copper is 1. Carbon's 1. Oxygen's 3. Copper is 1 on the right. Carbon's 1 on the right. And then the oxygen is 1 plus 2 is 3. So make sure you realize sometimes these are already balanced. Probably should have started with that one, but that's fine. You will have equations, that chemical reactions, where it's a 1-to-1 ratio across the board. That's fine, that happens. That does happen. Okay? All right. So you go ahead and do this, start on this last one. So I'll tell you, give you this hint though, these are formed. So our form means they're on the right side of the arrow. Let me be consistent with my colors here. So these two compounds, Zn and O3,2 and AgBr, are formed when ZnBr2 and AgNO3 react. So go ahead and pause the video, go ahead and do your atom inventory, do your count, and then go ahead and balance this one. There's no hints for this one, there's nothing by itself, so just work your way through. So go ahead and try that one on your own, see how that goes, and then you can start the video again and see how you did. Okay, so set up your inventory. We got some Zn, we got some Br, silver, nitrogen, and oxygen. On the left, we got 1 zinc, 2 bromines, 1 silver, 1 nitrogen, and 3 oxygens. On the right, we got 1 Zn, 1 zinc. Oops, what am I doing here? 1 zinc there. Bromine is 1 over there, so it's obviously not balanced, 2 and 1. Silver is 1. Nitrogen, now if it's a polyatomic, split it up. So nitrogen, remember this tells me I have 2 NO3s. So if it helps you, think about it like that. Or distribute in. So we've got 2 nitrogens on the right, and oxygen on the right, we have 2 times 3 is 6. So it's obviously not balanced. Definitely not balanced. Oops, excuse me. So no hints on this one, nothing by itself. So go ahead and just start your way through. Zinc's balanced. Go to the bromine. Put anything we want there. So let's put a 2. Check. Affects my silver though, so that goes to 2 there. 1 and 2. So I want to fix my silver over here. So I'll put a 2 there. That'll give me 2 silvers. And that affects a couple other things. So you got to make sure you do a recount. That gives me 2 nitrogens. 2 times 3 is 6 oxygens. Oh, look at that. So it just fell into place. And obviously, if it starts doing that for you, you're headed in the right direction. But sometimes, you just make a change or two, or add a coefficient or two, and it'll just fall into place for you. You know, obviously, that means you're headed in the right direction. I like to do the final check. 1 zinc, yep. 2 bromines, yep. 2 silvers, yep. 2 nitrogen, that works. 2 times 3 is 6 oxygen, 2 times 3 is 6 oxygen. So there you go. Okay. So hopefully that went pretty well. We'll be working on a little bit, we'll be working on more of these in class, and I'll show you a few more tricks in class too. So, all right, so thanks for watching the video, and make sure those notes are filled out, and then we'll talk more in class.